governance framework for Snowflake Cortex Code or CoCo. As organizations increasingly adopt AI assistant development and analytics capabilities, it becomes critical to ensure that innovation is balanced with cost control, security, and accountability. Our focus is on how we can establish effective governance, implement budget controls, provide visibility into AI, and create secure operating model that enables team to continue innovating without introducing uncontrolled credit consumption or unexpected cost. Our goal is to build guardrails, not roadblocks, allowing teams to move fast while maintaining financial and operational discipline. Hello everyone, my name is Chetan Surti. I am Snowflake Certified Architect, currently working as a principal architect, having 24 years of experience in data domain. The rapid adoption of Cortex code across Snowflake environments is creating a new challenges for enterprise organizations. Developers, data engineers, analysts, and business users now have AI-powered assistant available through multiple interfaces. While this drastically increasing productivity, it also introduces new category of consumption that often goes unnoticed until cost begin accumulating. Without governance, organization can experience unexpected credit consumption, lack of accountability for usage, uncontrolled experimentation, difficulty attributing cost to teams and individuals. The primary objective is not to restrict AI usage, rather, it is to eliminate known value generating spend while preserving engineering productivity and encouraging responsible experimentation. In short, visibility and governance must scale alongside. Cortex code can access through three primary interfaces, each serving different user communities and use cases. First is the Cortex CLI. It is primarily used by engineering and DevOps team for automation, infrastructure configuration, and scripting activities. Second is the Snowside Assistant, which provides AI-powered SQL assistant directly within Snowflake. This is particularly valuable for business analysts or BI user who needs help creating or optimizing queries. The third is CoCo Desktop, which is integrated directly into developer workflows and enable large-scale code generation, schema design, and pipeline development. Because each interface supports different workload and consumption patterns, governance cannot be applied uniformly. Each access channel requires its own monitoring, control, and credit allocation strategy. One of the most effective governance mechanisms is the implementation of daily budget caps. Historically, many organizations provide unrestricted access to AI tools, which often leads to inefficient consumption patterns. Instead, we should often lead to inefficient consumption patterns. Instead, we should transition to a cohort-based approach where users receive credit allocation aligned with their responsibility and business needs. The key benefits include predictable spending, better resource allocation, improved accountability, early detection of abnormal use. The objective is not to minimize AI usage, but to ensure that consumption align with business value and role requirement. The slides highlight how AI consumption is typically distributed across user groups. Based on historical observations, CoCo desktop users accounts for approximately 55% overall consumption, followed by Snowslide user represent about 30%, and CLI users consume approximately 15%. CoCo desktop category generally drives the highest usage because complex application development and code generation require large prompt volumes and longer interaction. Understanding this distribution allows organization to prioritize governance effort where the majority of consumption occurs. Instead of applying blanket restriction, we can focus controls on highest consumption cohort while maintaining flexibility for business critical activities. Governance becomes effective when it is aligned with the organizational roles. On this side, we establish differential limit based on use responsibilities. For example, data admin or system admin receive unrestricted access because they support enterprise-wide operations. Core data engineer receives moderate but critical daily limits. Business analysts are limited to Snowsite, while CLI and CoCo desktop access may be restricted. External vendors receive the restricted control and enhanced monitoring. The role-based framework enables us to balance productivity, security, and cost management. The principle is simple. Provide access proportional to business responsibility and expected usage pattern. The budgeting model begins at the account level and is then distributed across users. Several key principles guide this framework. First, budgeting is based on total monthly account consumption. Second, user thresholds are calculated once during each budgeting cycle and remain consistent throughout the period. Third, available budget capacity is allocated across provision Cortex users based on organizational priorities. Finally, these controls apply specifically to Cortex code. Other Cortex services continue to operate independently under their own governance mechanism. This approach creates predictability and simplifies financial planning while ensuring fair resource allocation. The slide outline a four ways implementation strategy. The first step is securing the environment by eliminating unrestricted access control granted through default roles. Next, we establish dedicated Cortex code roles with clearly defined privileges and access boundaries. This allows administrator to separate access by use case and user population. While historical account consumption, AI adoption rate, working day assumption, and safety factors, we calculate user level credit budget. This provides a data driven method for assigning limits. The last, we automate governance, monitoring procedures regularly evaluate usage, generate alerts when thresholds are reached, and take corrective action such as disabling access until limits are reached. This transforms governance from the manual process into continuous managed operational capability. This slide demonstrates how governance policies are implemented through Snowflake role-based access control. We create dedicated AI governance roles and assign them to the appropriate users. Once users are assigned to cohort, we can enforce limit directly through user level configuration setting. Example, enabling higher limit for power developers, restricting BI user to approved interface, blocking CL access entirely for specific group. Advantage of this model is flexibility. Administrator can easily adjust permission, budgets, and access level without redesigning the entire governance framework. Everything becomes auditable, manageable, and aligned with the enterprise security standard. The successful governance requires a phased rollout rather than a sudden enforcement model. The first phase is 1 to 30 days. During the first phase, we collect consumption data, establish baselines, and deploy monitoring capabilities. The primary goal here is visibility. Next, we introduce user group segmentation, role-based governance policies, and soft budget limits. This phase focuses on behavioral adoption and stakeholder alignment. Finally, we move towards automated enforcement and spending limits. proactive notification, and continuous optimization. Regular reviews ensure governance evolves alongside business needs and AI adoption pattern. This phased approach minimizes disruption while maximizing long-term effectiveness. Let's jump to a live demo. So here uh, we'll show you. I downloaded the repository. I clone it. I move to the place, and here you can find one config.yml file. You just need to set this. So I just change the config.yml file in such a way. Cortex management is my database. The schema name. This is my roles which I will use, and I will use the account admin role. Now I will show you. You can just clone the repository. You can go to command prompt and just mention this. Here you find uh, all the my scripts. The second phase is you can deploy your code using the command like this is the command I use. Then I will use database. I will use schema and just enter. It will deploy your entire Streamlit code into Snowflake. This is the application I just built to see all the part we discuss how we govern and implement it. This is a Streamlit based small application which we can use to run the establish the setup. You can perform all the activities which we discuss in demo through this application. It is available on Snowflake repository. Let's show the demo how it works. I will walk through the application which we built just now. So here when you deploy, you will see this application. This is a Streamlit application. You can go to project and click on Streamlit and you can find this Cortex Code Credit Manager. Click on this application. First, you need to configure it. So when it loaded, go to setup. Here, you just need to run check. So it will check if any object is missing or not. If it's missing, just click on create missing objects and it will deploy all the required objects into Streamlit. Okay. Now just again run check. It will show you all the objects are see you are expecting 12 tables, SP store procedures, 14 store procedure, task, roles, and that's it. So now you need whatever role it created, like this or four roles it created, grant this roles to own. Like I created, I assign it to my user Chetan Surti. Now just see default setting, so it will seed at this time, and r- just run initial route. So it will capture copy data from account user to own metadata. So with this, my application is ready to monitor and governance. Okay. So what all things I can do with this application? So first is let's let me finish. It will so it's finished. Now go to access management. So you if you want to grant Cortex code access to individual user or account level or the user with tagging, you can do it from here itself. Like I want to give user this access to individual user, just search for individual user, just type here, it will search like desktop user. I wanted to give apply grants, just apply it and it will grant access to this user. Okay. You can also set up at account level, which is not recommended for small, but if it's a big scale, you can do that. You can apply a grant based on the tag also. Like if you want to give finance or marketing, you can grant this. Second, you can also check which all roles and user is having code text code access. Okay, and you can see this as well. Now, second is important part is credit consumption. Right now, I have defined 20 credits to CLI, 20 to Snowside, and 20 to desktop. But I can change. Suppose I want to reduce this. Okay, I just wanted to give only 10 and desktop limit to say 30 and just I apply. So by it will change CLI to 10, uh, Snowside to 20, and desktop to 30. So when I click again, it will change this. Okay. Now, as we discuss in demo, cohort is the best practice to assign the credit. So you can assign like just wanted to give um, for this demo purpose, I created role called CoCo in CoCo UI CLI role. Suppose okay, I just wanted to give CLI credit to 20 and 0, 5, and this is 5. You know. Now I just apply. I can choose whether it's a permanent or it's temporary. Okay. And then I just apply and it will automatically apply to this. Okay. Apply to one user, that is now user override. I mean, whatever credit is there, if you want to override that, then I can do it from here itself. So this is very useful setting. From one place you can control complete credit. Okay. You can also monitor what is the credit usage trend. Okay. You can also do a forecasting. Very important part here is tier. You can define a tier like tier one, tier two, tier three. It's the name is up to you. In which like tier, which tier is using which data model. That is important. Like see if you go, you can see what data models they are using. This is the data model. You can add, remove. So you can control access of accessing model through tier. You can create your own new tier and as many as tier if you want. And you can also check which all available models and which model is consuming which credits. So based on that, you can take a decision. Okay. You can map this tier with respective roles. So the role, if you assign role to, suppose one role you assign tier one, and if you assign that role to a user, automatically this tier one will assign to a user. So this is the very important features. Next, like you can, I mean, user can raise a request, like they want, suppose in CLI credit they want 10, so they just need to submit a request. Okay, and here you can see the whatever who is admin. Right now I am admin, so I received a request. I just need to approve it. So now the person will get the creditors. It will take some time, but yeah. So how it will decide which uh how, because the credit is fixed for that cycle, budget cycle. So it will revoke credit. How it assigns. So now for that we just need to go to setting. You can see there are four way. One is weighted random, highest surplus, the having the role having maximum credit, but it's not in use. So one, you can assign credit from that particular. It is called highest surplus. Minimum donor, like I mean now everyone is having same credit, but they will if you I choose this, then it will the pick the person who has donated less credit, the limited credit, okay? And round robin is pick up randomly and assign, okay? So this is the way it will configure how and which credit from which roles or users it will pick. So this is a really, really very important uh, application. You can download, you can explore it, and that's all about today's demo. Thank you for your time and attention. To summarize, successful code adoption requires three key capabilities: visibility into consumption, governance through role based control, proactive budgeting and monitoring. By implementing these guardrails, organization can enable responsible AI usage, improve financial predictability, and maximize the business value of Snowflake Cortex Code. I would be happy to answer any of questions and discuss. Just drop in channel and I will publish it. Thank you so much.